Hello everyone. So let's revise Bayes theorem quickly. So let's say you are testing the reliability of a particular disease test. Okay. So of the people having the disease, okay, people who have the disease, if they undergo this test, if they undergo the test, okay, then 90% of them are correctly detected as positive, okay, and there is also a 10% chance of a person having a disease but still being not detected as positive. Okay. Okay. On the other hand, of the people who don't have the disease, okay, who don't have the disease, of those people, no, 99% are correctly identified as negative cases, okay, but there is also a chance of 1% people who don't have the disease but still getting detected as positive. Okay. Now the actual ground truth is, okay, you can say that this is the ground truth, basically, that only 1% of the population, or not even 1, let's say only 0.1% of the population actually has the disease. That is our ground truth or estimate. Okay. Only 0.1% of the population actually has the disease. Okay. Now, one person who actually undergoes the test, okay, and the result of the test, okay, so let's say person X detected as positive after going through this test, what is the probability that, okay, what is the probability that X has the disease, X actually has the disease, X actually the disease. Okay. Okay. So now to solve this by Bayes theorem, okay, so let E be the event that X has the disease. Okay, and let A be the event that the test of X comes out to be positive. Okay. Now, from the data that is given in the question, probability of E, probability of the person having the disease is 0.1%, which is 0.1 divided by 100, which is 0.001. Okay. Now, okay, let's keep solving this. Okay, so the probability that the test of the person comes out as positive given the person actually has the disease, okay, that is 90%. This is again from the given data, and if we write in terms of probability is 0.9, and the probability that the test comes out as positive but the person does not have the disease, this is E complement. If E is X has the disease, then E complement is that the person does not have the disease. So the probability of A given E complement is equal to 1%. This is from the given data, right? The probability that, okay, if I just zoom it out a bit, okay, the probability that the test comes out as positive, this is test comes out as positive and the person has the disease, this is the probability that the test comes out as positive even though the person does not have the disease. Okay, so I hope these values are clear to you. Now we'll apply the Bayes theorem. So what what we are trying to predict with the Bayes theorem is probability of E given X. Probability of E given A, right? What is probability of E given A? What we are trying to find, what is the probability that E, that is the person has the disease, what is the probability that X actually has the disease? So probability of E given that A has already happened. So given that the test has already come out as positive. Okay. So probability of E given A is probability of E multiplied by probability of A given E divided by probability of E into probability of A given E plus probability of E complement multiplied by probability of A given E complement. Okay, so substituting all the values, from here. Okay, if probability of E is this, the probability of E complement will be 1 minus this, which is 0.999. Okay, so accordingly if you substitute all the values, this will come out to be 0.083. So there is a 0.083 probability that given, like if the test has come out as positive, the probability that the person actually has this disease is 0.083. So this was a quick revision of the Bayes theorem, and in the next video we'll move on to what is the naive Bayes classifier.